Lesson 3. What are the structure and features of tropical storms? What is the structure of a tropical storm? Contrary to how many weather maps appear, a hurricane is more than a point on a weather map, and its path is more than just a line. It is a large system that can affect a wide area, requiring that precautions be taken far from where the eye is predicted to come ashore. This section will discuss the different parts of the hurricane, and you will get a better understanding of the hurricane hazards that ensue. The main parts of hurricanes are the rain bands on its outer edges, the eye and the eye wall. Air spirals in towards the center in a counterclockwise pattern and out the top in the opposite direction. In the very center of the storm, air sinks from the cloud-free eye. The hurricane center is relatively calm, clear, usually 20 to 40 miles across. People in the midst of a hurricane are often amazed at how the fierce winds and rain can suddenly stop and the sky clear when the eye comes over them. Then, just as quickly, the winds and rain begin again, but this time from the opposite direction. The eye wall. The dense wall of thunderstorms surrounding the eye has the strongest winds within the storm. Changes in the structure of the eye and eye wall can cause changes in the wind speed, which is an indicator of the storm's intensity. The eye can grow or shrink in size, and double eye walls can form. The storm's outer rain bands, often with hurricane or tropical storm force winds, can extend a few hundred miles from the center. Hurricane Andrew in 1992 had rain bands reach only 100 miles out from the eye, while those in Hurricane Gilbert in 1988 stretched over 500 miles. These dense bands of thunderstorms, which spiral slowly counterclockwise, range in width from a few miles to tens of miles and are 50 to 300 miles long. Sometimes the bands and the eye are obscured by high-level clouds, making it difficult for forecasters to use satellite imagery to monitor the storm. Hurricane size. Typical hurricanes are about 300 miles wide, although they can vary considerably. Size is not necessarily an indication of hurricane intensity, however. Hurricane Andrew in 1992, the most devastating hurricane of the century, was a relatively small hurricane. Don't focus on the location and track of the center, because the hurricane's destructive winds and rains cover a wide area. Hurricane force winds can extend outwards of about 25 miles from the storm center of a small hurricane and to more than 150 miles for a large one. The area over which tropical storm force winds occur is even greater, ranging as far out as almost 300 miles from the eye of the large hurricane. Hurricane circulation and movement. In the northern hemisphere, hurricane winds circulate around the center of counterclockwise fashion. This means that the wind direction at your location depends on where the hurricane's eye is. A hurricane's speed and path depend on complex interactions between the storm with its own internal circulations and the Earth's atmosphere. The air in which the hurricane is embedded is a constantly moving and changing river of air. Other features in that flow, such as high and low pressure systems, can greatly alter the speed and the path of the hurricane. In turn, it can modify the environment around the storm. Typically, a hurricane's forward speed averages around 50 to 20 miles an hour. However, some hurricanes can stall, often causing devastatingly heavy rain. Others can accelerate to more than 60 miles an hour. Hurricane Hazel in 1954 hit North Carolina on the morning of 15th of October. 14 hours later, it reached Toronto, Canada, where it caused 80 deaths. Some hurricanes follow a fairly straight course, while others loop and wobble along the path. As a general rule of thumb, the hurricane's right side, relative to the direction it's traveling, is the most dangerous part of the storm because of the additive effect of hurricane wind speed and speed of the larger atmospheric flow, the steering winds. The increased winds on the right side increase the storm surge described in the hazard section. Tornadoes are also common here. However, so how will climate change affect tropical storms? A warmer, wetter atmosphere could also affect tropical storms, but changes in tropical storms are harder to predict and track. Some scientists have speculated that a warm climate that allows more intense storms to develop would also spawn more hurricanes. Tropical cyclone activity is the subject of an ongoing debate and research in the scientific community. Recent catastrophic events such as Hurricane Katrina have given the debate a higher profile, while some evidence has been presented in order to indicate a recent upturn in tropical cyclone activity in some parts of the world. Others have argued that natural variations in tropical cyclone activity on a regional, annual, and interdecadal scale mask any signal from the impact of global warming, which remains relatively small. Although there is no clear consensus on whether global warming is currently having a measurable impact on tropical cyclones, climate models indicate that there may be an increase in tropical cyclone intensity in the future under continued global warming. However, the models also indicate the tropical cyclone frequency will either remain unchanged or decrease. Climate change is likely to affect the distribution, frequency, and intensity of tropical storms in the future. For the first time, we have seen hurricanes in the southern hemisphere. In Brazil in 2004 and recently in 2016 in Fiji. As sea temperatures change, this is increasingly likely to affect the distribution of tropical storms. Furthermore, since records began in 1878, we are increasingly seeing more intense tropical storm activity since 1995. While some computer modeling has been undertaken by scientists, we still do not have a clear knowledge of what may happen in the future.